If you're not affected by the gas prices, man. I guess you're not affected by the gas prices, if that's your mode of transport.
That depends.
I've been having some issues with the Wi-Fi earlier, um, with the previous class, so I'm hoping everything will work out smoothly, more smoothly this time around. Oh, hold on, somebody just left the message. Email you via Canada about this, I'm not sure if you've seen it yet. Oh, okay, okay, hold on, I'm confused, but, we can talk later, Miss Jordan, about that. Okay, let's get started with what we're going to discuss today, which deals with something that you need, it's a skill that you have to master in order for you to progress in this course, and not only this course, but any other course which involves chemistry, all right? And that is chemical equation, all right? Chemical equation is basically a shorthand way of describing what is happening in a chemical reaction. So we tend to use this in terms of, instead of writing out basically what the reaction would be in words, all right? So as stated here, a chemical equation basically provides us a means to summarize the reaction and to display the substances that are reacting, to show the products, and to some extent show what the relative amount of the different substances involved in a reaction, and in some extent also to give some information about the conditions of the reaction, all right? So, of course, in a chemical reaction, there's a change in the composition and or structure of the different substances involved. And this would involve atoms, molecules, or ions rearranging themselves and coming together to form different compounds or different substances. So those substances that are reacting, we call them the reactants, right? And then, of course, the substances that are formed as a result of the reaction, we call them products, all right? And of course, as we go from reactions to products, as I said before, there'll be rearrangement. You might have some, well, more than likely, you will have some bond breaking and bond making occurring to result in the formation of new compounds, all right? So this is basically what a chemical equation is. It's a shorthand way of expressing a chemical change, all right? Now, in a chemical equation, you can actually use words in a chemical equation. So you can literally write down the name of different compounds. But in chemistry, we try to even avoid that and use formulas instead, right? That is more convenient to do so. So for example, let's look at this particular equation, right? So as you can see from this equation, okay, just as I said, there's some problem that I'm experiencing right now. Uh, let's see. Alrighty, back in business. So as I was saying, we're going to look at this example here. So this is a reaction. I don't know how many of you have heard of the thermite reaction, a very explosive reaction. I'm quite sure if you go to YouTube right now, you can see some examples of it. All right. So this is the reaction. If you mix up these two compounds, iron 3 oxide with aluminum, and then you ignite it, you get a big what we call an exothermic reaction. An exothermic reaction is a reaction that generates heat. And in this case, it generates heat and light, right? So this is the chemical equation that we're going to use to represent that reaction. You have the reactants on the left side, which would be the aluminum, along with the iron 3 oxide on the left side. And on the right side, you're going to have iron and the aluminum oxide, right? Which would be the products, okay? So this is showing you that aluminum plus iron 3 oxide gives you iron and aluminum oxide, right? So obviously, there is, just based on the formulas alone, even without knowledge of the structure of these compounds, based on the formulas alone, you can tell that there's bond breaking and bond formation occurring, right? Because obviously, to get from the reactants to the products, you'd have to separate the iron and the oxygen, right? That's why you end up with the iron on this side. So there's some bond breaking taking place between the iron and the oxygen. And then on this side here, the aluminum must be bonded to the oxygen to form the products, right? So basically, you have bond breaking here between the iron and the oxygen, and then you have bond formation between the aluminum and the oxygen, right? And that's basically what you'll observe in pretty much all chemical reactions. You have bond breaking and bond formation to form new products, right? Now, another important aspect of writing down a correct balance equation is that the equation must represent the quantitative relationships that exist between the reactants and the products, right? So basically, in a balanced equation, which reflects that, we need to use what are known as coefficients, which are integers, which are placed in front of the formulas of the substances to indicate the balance, right? Now, the balance is important because of the conservation of mass law. The conservation of mass law says that matter is not created nor destroyed in any chemical or physical process, all right? And the reason why that is true is explained by Dalton's theory. And one of the assumptions of Dalton's theory is that in a chemical reactions, atoms are not created nor destroyed, right? So whatever the same number of atoms of each element that exist on the reactant side must be equal to the same number of atoms of each element on the product side. And the equation must reflect that. Now, going back to this example right here, this equation does not reflect that. Why? Because you'll notice here that there's one aluminum atom represented here, but there's a subscript 2 here, which indicates that there are 2 aluminum atoms, right? So obviously, the number of aluminum atoms are not the same on both sides. So therefore, based on that fact alone, we can come to the conclusion that the equation as it is written is not balanced, right? In other words, it does not reflect proportionally the amount of aluminum or aluminum oxide that is present as reactants or products. Also, by the same token, if you compare the iron on the left side with the iron on the right side, again, there's an imbalance right there, right? Because you have 2 iron atoms represented here, but there's only one here. So again, based on that, we can conclude that the equation is not balanced, right? So in order to balance it, we have to place the appropriate coefficients to ensure that the number of atoms of each element on either side of the equation would be the same. And in this particular case,
right now,
that would mean that we would put a 2 here in front of the aluminum, so as to balance with the aluminum on this side here, and we put a 2 here in front of the iron to ensure that this number of iron atoms will be equal to the number of iron atoms here, right? And as far as the oxygen is concerned, it's already balanced because you have 3 here and you have 3 here, right? So now we can come to the conclusion that this equation is balanced. And this is something that you have to learn to do in order to, for one, balance equation, and then two, because equations are balanced, you can use the information based on the balance equation to solve other problems, which we're going to get into when we get to chapter, if I'm not mistaken, 7 or 8. All right. So that's basically what's involved in a balanced equation. Or somebody's saying that I'm echoing really bad. Okay, I don't know what to do. Oh, let me do this. I think I know what the problem is. Okay, how about that, Ashlyn? Okay. I think I've resolved that problem. Thank you very much. Okay, good. Thank you. All right. So that's how the equation, that's how you balance an equation. Now, that's a relatively simple example. Let me see what comes up here. In some cases, and I've mentioned this before, equations can be written such that it gives you information about the conditions of the different substances involved, but also the overall condition of the reaction. And in that case, you can put the information above or below the arrow, such as a symbol like this. So if you see a symbol like this, it's a small triangle. Basically, that means that you're heating the mixture in order to drive the reaction to take place, right? In other cases, you might be giving even more specific information. So you could be given something like this, 400 degrees Celsius, for example, right? Which gives you more specific information about the conditions for this reaction. In some cases, which will become important in some cases, you may be given information about the state of the different substances involved. And we use what is called, or what are called state symbols, right? So, for example, L in parentheses stands for liquid, right? If you put that beside the formula for the substance, you're saying that the substance is a liquid, right? So here is that applied to this equation that we just looked at. So as you can see here, you see S, S, L, L. I mean S for the aluminum oxide. So S stands for solid, L stands for liquid, and you can put G for gas, and AQ for aqueous solution, all right? And as I stated before, as you go from the reactants to the products, atoms are not created nor destroyed. Whatever the number of atoms of each element present on the left side, it's going to be the same on the right side. So you have 2 aluminums here, 2 aluminums here, 2 irons here, 2 irons represented here, 3 oxygens here, and 3 oxygens here, all right? And so as stated here, all atoms present in the reactant must also be present in the products in the same numbers, all right? We talked about symbols. Well, this one we didn't talk about. The plus sign, we simply put them between the substances on either side of the equation. The arrow indicates the direction of the reaction from reactants to products. S stands for solid, L stands for liquid, G stands for gas, and AQ stands for the fact that the substance is dissolved in water, aqueous, all right? Delta or triangle, that's a symbol placed above or below the arrow, which stands for heat. And H nu, I'm not going to explain what H nu actually means, excepting that that combination is used to represent light energy. There are some reactions which require light in order for the reaction to take place. Now, this symbol, to be perfectly honest, it's not used too often. I hardly see it used nowadays. But basically, if you have a triangle, an arrow put beside a substance, it means that it's a gas being formed. And then there's another one which I haven't seen in a long time. If the arrow is pointing down, it means that the substance forms a solid, all right? But to be perfectly honest, I haven't seen those symbols being used in a long time, all right? Okay, so now we're going to get into how do we go about balancing an equation, right? So basically, to balance an equation, you need to adjust the coefficients so that the number of atoms of each element on either side will be the same. And in some cases, it's a kind of combination of systematic and trial and error process in order to achieve this. All right, and you're going to see some example of how this is done. One thing you should not do, right? You should not change the formula of any of the substances involved in a reaction. So basically, what they're saying is that you should not make any adjustments to any of the subscripts that you see in the formula, right? The only thing that you should adjust should be the coefficients, all right? Okay, so let's go through the steps. The first step is identify the reaction. Now, you may or may not find this necessary to do, but it says here to write a description or word equation for the reaction. It all depends on the type of question you're given. So in this case, you're given the statement. Mercury 2 oxide decomposes to form mercury and oxygen. So if you were to write down a word equation for this, it's going to look something like this, right? You're going to have mercury 2 oxide, which would be the only reactant in this reaction. On the right, on the left side, and then on the right side, you're going to have mercury and oxygen written down. All right. You might not find this necessary to do. I don't find it necessary to do, but if you find it helpful, that's fine by me. All right. So after writing down the word equation, then you're going to write down an unbalanced equation based on the word equation, right? So basically, you're going to write down the formula of the reactants and the products on either side. The reactants will be on the left, the products will be on the right of the arrow, right? So if you do that, this is what you're going to end up with in the particular example that we just started off with. So the formula of mercury 2 oxide is HgO, and the formula for mercury is Hg, and the formula for oxygen is O2. And I think I remember telling you that, and I'll remind you if you have forgotten, that there are 7 elements that exist as diatomic elements. Did I tell you that? Right, so you need to remember those 7 elements. Oxygen is one of them. And this is the reason why you need to know those elements, because you might be tempted to just put O and that's it, but the actual formula should be O2, all right? So once you've written down the equation, this equation will be unbalanced, right? Clearly because you have 2 oxygen atoms here on the right side and only 1 represented here on the left side. So now the next step is where you have to balance the equation. But remember again, in balancing an equation, you do not make changes to the formulas, right? So you do not, for example, remove this 2 here or add any other subscripts to any other formulas, all right? Now, to balance the equation, what we do now is count and compare the number of atoms of each element on either side. And therefore, based on that, you're going to determine which of the elements would require balancing, right? So if we look on both sides, you see that you have one mercury atom represented on each side. So for now, the mercury atoms are balanced, right? However, in the case of the oxygen atoms, there's obviously an imbalance. You have 2 oxygen atoms on the right, 1 oxygen atom on the left. So the question now becomes, how do we balance the oxygens, all right? So the way we balance the oxygens is that we place a number such that beside one particular formula, such that you achieve the balance of the oxygen. So where would that number go, and what would that number be? That number would be a number 2 that you place here, all right, in front of the mercury 2 oxide, because when you place a 2 here, then that coefficient changes from 1 to 2, and that balances with the 2 oxygens on the right, okay? So therefore, the oxygens are now balanced, all right? However, because of the 2 that we placed here, that results in an imbalance of the mercury atom, because now we have 2 mercury atoms here, and we have 1 here, right? So basically, what that means is we have to place an integer, a coefficient of 2, in front of the mercury, right? So this is how we do it. We place a 2 in front of the mercury here to achieve that balance, and therefore now the mercury atoms are balanced on both sides. And then what I normally tell my students is that after balancing all the atoms, you do final one quick check through just to make sure that everything is balanced. And that's the case here. You have 2 mercury atoms on both sides. You have 2 oxygen atoms on both sides. So now the equation is balanced, right? So that's basically showing you us taking account of that. And therefore, that's how that is done, all right? So that's a relatively simple example, but basically those are the steps that you'd have to go through in order to balance an equation such as this one. Okay, any questions about this example that we have just looked at? Any question? Any question? Okay, so let's look at this other example. In this case here, whoops, we have sulfuric acid reacting with sodium hydroxide to form sodium sulfate and water, all right? So the first step is that we need to write down the formulas of the different substances. So this is where what you learned in the previous chapter when it comes to nomenclature, naming compounds. All the rules that you learned about naming compounds will come into play here. Because if you're given the name of the compound in words, then you have to figure out what the correct formula is before you can actually go into balancing the equation. So in the case of sulfuric acid, the formula for sulfuric acid is H2SO4, right? And then in the case of sodium hydroxide, it is NaOH. And then on the product side, the formula for sodium sulfate is Na2SO4. And then we add water. Everybody knows the formula for water is H2O. So that is what the first thing you do. And then you have to balance this equation. All right. So we have to go through the steps similar to what we just did in the case of the previous example, right? So what I would do is first start off by looking at the hydrogens on both sides, right? Well, in fact, let me just say here that I wouldn't start with a hydrogen quite yet. And the reason why is because the hydrogens are shared between 2 substances on the left side. And you have hydrogen here in only 1 compound. So what I will do next is look at the sulfur. There's 1 sulfur atom here, 1 sulfur atom here, so that's fine. I would look at the oxygens quite yet for the same reason, but I will look at the sodium, right? And what do I notice? You have 1 sodium atom here, and you have 2 sodium atoms here. So I'll put 2 in front of the sodium right here, right? To balance the sodium, right? And then now I will look at the other atom. Now in the case of hydrogen, there is 2 here plus 2, so that's 4. There's only 2 here, so I will put a 2 here to balance the hydrogens, all right? And then as far as the oxygens are concerned, you have 4 here plus 2, that's 6. Here we have 4 plus 2, 6. So now the equation is balanced. All right, and that's how you do that. Okay, any questions about this one? Any questions? Any questions? Nope. All right. Let's do another example. Okay, let me clear this. So in this case, they gave you butane plus oxygen to give you carbon dioxide and water. Now, to be fair to you guys, you would know what butane is, what the formula is. So I'm going to write down the formula for butane here, which is C4H10. All right, that's the formula for butane. And it's reacting with oxygen. Again, remember, oxygen is one of those elements that exists as a diatomic molecule. So therefore, O2, right? And then the formula for carbon dioxide is CO2. And the formula for water is, of course, H2O. All right? Now, let's hear what you have to say about this. How would you go about balancing this particular equation? Okay, so somebody's saying that they can't hear me. Okay, anybody else out there in Zoom having audio problems? Okay, somebody said that they can't hear me just fine. Okay, so I don't know what the issue is. I'm just going to continue. Of course, this is being recorded, so I'm going to post it online. So anything that you have missed, you should be able to get it if you play back the video. All right, so let me hear your suggestions as to how you go about balancing this equation. Let's look at the carbons first. How many carbons do we have on the left side of the equation?
4.
4. How many do we have on the right side? 1, right? So how would you achieve the balance of the carbons on both sides?
Put a 4 in front of the C on the left side.
With a 4 in front of the CO2, all right? So that achieves the balance of the carbon. Okay, what about the hydrogens? How many hydrogens do we have on the left side? 10. How many do we have on the right side? 2. So how do we achieve the balance of the hydrogens?
5.
Put a 5 in front of the H2O, exactly. Okay, very good. So now we get to the oxygens, all right? How many oxygens do we have on the left side? 2. How many oxygens do we have on the right side?
12.
12. How do you get 12?
Times the 4.
4 times 2, 8,
And then the 5.
plus 5. So that's 8 plus 5, that's what? 13, right? So the question now is, how do we achieve the balance of oxygens on both sides? You have 2 on one side, you have 13 on the other side. Any ideas? Any ideas out there in Zoom? Okay, so this is a little trick that you can employ when it comes to a situation like this. So since you have 13 oxygens on the right side and you have only 2 on this side, what you can do is multiply the oxygen by 13 over 2, right? Because 2 times 13 over 2 gives you what? 13, which balances with the 13 on the right side, right? However, this is not the final answer because when we balance equations, we try to end up with integers as coefficients for all the substances involved, right? So the next step would be, in order to get the final answer, is to multiply everything by 2, right? Because you want to make sure that all these numbers here are integers, including the number here in front of the oxygen. So if you multiply everything by 2, you're going to get 2C4H10 plus 13O2 to give 8CO2 plus 10H2O. And that should be, folks, the final answer. All right. And again, I would recommend you just do a check through to make sure that everything is balanced. So if you do that, starting with the carbon, 2 times 4, 8 carbons, 8 carbons on the side. So the carbons are okay. 2 times 10, 20 hydrogens, 10 times 2, 20. So the hydrogens are balanced. And then for the oxygens, it's 13 times 2, that gives you 26 oxygens. Here we have 8 times 2, 10. I'm sorry, 8 times 2, 16 oxygens, plus 10, 26 oxygens. So the oxygens are balanced as well. All right? And that's how you do that. Okay, any questions about this one? Any questions? Any questions? Okay, okay, so just some general information here concerning the type of information you can get from a balanced equation, right? Now the formula of any particular substance can mean something depending on the context. For example, H2O basically can tell you a couple of things. It tells you that in one molecule of this particular substance, there are 2 hydrogen atoms and 1 oxygen atom. It can represent also 1 molecule of water. So it all depends on the context, right? And then in an equation, the formulas can represent units of an individual entity or moles. And later on, we're going to look more deeply into this whole term moles, so that you can see the relationship between that and the coefficients of the substances in an equation. So let's look at this example. The reaction between hydrogen and chlorine to form hydrogen chloride. As you can see, based on what we have learned earlier, this is a balanced equation. So one way of interpreting this equation is that 1 molecule of chlorine is going to react with 1 molecule of hydrogen to form 2 molecules of hydrogen chloride. All right, so that's one way of representing it. Here's another example. In this case, we're reacting propane with oxygen and the products will be carbon dioxide and water. And this is the equation right here, right? And there are several ways of interpreting what we're looking at here. For example, we can say that one molecule of propane will react with 5 molecules of oxygen to form 3 molecules of carbon dioxide and 4 molecules of water, right? And then we can break it down further in terms of looking at the actual number of atoms involved in the reaction as reactants and products. And of course, you're going to see that it's balanced, and therefore the number of atoms of each element on either side will be the same. So for example, here we have 3 carbon atoms and 8 hydrogen atoms coming from propane and 10 atoms of oxygen coming from oxygen. And then over here, we have 3 carbon atoms, 6 oxygen atoms coming from carbon dioxide, 8 atoms of hydrogen, and 4 atoms of oxygen coming from water. And if you count up the number of atoms of each element on either side, basically that's what you're going to see. You're going to see that the number of atoms of each element will be the same on both sides. And then if you look at the masses, right? We have not done moles yet, but we're going to get to that later on. But if you look at the actual masses of the different elements or atoms involved, right? If you add up the total mass here and the total mass here, that sum would be equal to the total mass here and here. And that's basically indicating that mass is conserved in this particular chemical reaction. Okay, so that's as far as that is concerned. And that's basically the end of this chapter. So now, for the rest of this class, you'll be working on this assignment number 6. And it's all about balancing equations. It's a very important skill that you need to master. And that's why I'm basically making you go through this, because as you're going to see, oh, I'm sorry.
We never finished chapter 5.
Oh, we didn't finish chapter 5? Oh, my bad. Oh, I forgot. Where did we get in chapter 5?
Oh, we only had the acids left.
Oh, cool. All right. That's not too much to do. So, okay. So how do we name acids? I'm sorry about that. What you're experiencing is one of my senior moments. So please forgive me. Please forgive me. All right. So, to name acids, there are a couple of approaches you can take. All right. The approach I prefer to take when it comes to knowing or learning how to name acids is that I would start off with the corresponding anions, right? Now, what I'm going to do first is start off with naming binary acids. So let me tell you what binary acids are first. Binary acids, whoops. Binary acids are acids that contain hydrogen and one other non-metallic element. Let me specify. Non-metallic element. All right. So a good example, let me just name a couple of examples of binary acids. For example, H2S, aqueous, and another one would be HCl aqueous, all right? So these are 2 examples of what we call binary acids, right? They're made up of hydrogen. One of the 2 elements is hydrogen, but the other element is a non-metallic element, all right? Now, how do we go about naming these acids? What I like to do is start from the particular anion, all right? So basically, I'm going to use this as an example. The anion from which this acid will be formed would be S minus, right? Which is called the sulfide ion. In fact, let me construct a little table here, which should probably make things a bit easier to understand. So at the head of this table over this side, I'm going to put an ion, and then the name. No, let me do the other way. Name, then an ion. So the name, then the anion, all right? Then the name, then the formula for the anion, I'm sorry, formula for the acid. Formula of acid. And then here, the name of the acid. All right. Okay. So let me draw a line here. Okay. So I'm going to use H2S as an example, right? So in the case of H2S, the anion will be S2 minus, right? And if you look in the tables, remember I gave you in the packet, I gave you the list of anions. You can use that to look up the name, all right? So if you look it up, you're going to see that the name of the anion is sulfide. All right? That's the name of the anion, right? Now, to get the formula of the acid, what you do is take into account that you have two negative charges here, which means that you have to add two hydrogen ions to it, and therefore the formula becomes H2S, right? So that would be the formula of the, oh shoot, I just remembered something. Okay, let me put H2 gas here, right? So I'm sorry about this, folks. I'm going to include another column. Let me just get this out of the way here. And let me do this here. Okay. So here I'm going to put the name of the I'm trying to find the right terminology. That's what I'm trying to do. Let me erase this here. All right, since I'm drawing a black, let me just write here formula when H plus is added. I'm sorry about this, folks. Formula when H plus is added, okay? And then this would be the formula, this would be the name of compound formed from this, all right? And then name of acid. And I'm going to explain why I added that extra column right here. Okay, so when you add H plus to the S2 minus, right, you're going to get H2S. H2S is a gas, right? And in fact, in this particular case, H2S is a very awfully smelling gas. It smells like rotten eggs, right? And that's because rotten eggs, when decomposed, some of the proteins decompose to form this gas. So that gas is what you're smelling when you smell rotten eggs, all right? Now, to get from this compound to the corresponding acid, what you'd have to do is add it to water. So it becomes H2S, I'm sorry, it becomes H2S aqueous, and that should be placed not here, but I'm gonna just put it here, H2S aqueous, all right? So to get from H2S gas to H2S aqueous, you add it to water, right? Plus H2O, right? So basically, this is hydrogen sulfide gas, and this would be H2S in aqueous solution. And so this is called hydrogen sulfide. Sulfide. And this is H2S aqueous, and the name of this acid is hydrosulfuric acid. All right. So just to briefly go over what I just did, right? So what I did was that I started off with the S2 minus, right? The anion, right? You add 2H plus to it, and that forms hydrogen sulfide, right? The hydrogen sulfide is not itself the acid. The acid is formed when you add it to the water, right? And therefore, the solution, resulting solution is now an acid, and that has a different name. The name of that acid is hydrosulfuric acid. And this is basically how you go about naming any acid that is a binary acid. You start off with the name hydro to begin with, then the stem of the name of the other element, and then you end it with uric acid, or ic acid, I should say, all right? So that's how you do that. So in the case of the other example, you have chloride, CHLORDIE. Now in this case, you only need to add one hydrogen ion to form HCl, which is also a gas, all right? And then now the name of the compound as a result of the addition of the H plus, that is called hydrogen chloride. All right. And then when added to water, it becomes HCl aqueous. HCl aqueous. And the name of that acid is hydrochloric acid. Hope I can fit this down here. Acid, all right? So again, you see the pattern emerging when it comes to naming binary acids. The name starts off with hydro first, then the stem of the name of the other element. In this case, it was sulfur. In the case of chlorine, it's chloro. And then, or chlor, I should say. And then the rest would be ic acid. So it's hydro, stem of the name of the other element, and then ic acid, all right? So that's basically how you go about naming binary acids, all right? So just to see if you understand how this is done, suppose I gave you H2SE aqueous, right? And I ask you what the name of that acid is, right? Well, the corresponding anion is the selenide ion, which you can look up in the tables, as I said before. So to add H2 to this, or 2H plus to this, you're going to get H2SE gas, and this is called hydrogen selenide. And then when you add this to water, you get the acidic solution. So what do you think the name of the acidic solution is? Based on what we did in the previous two examples, what do you think the name of this acid solution is? Remember, the name starts off with what? Hydro, then? Well, actually, yes, you're right, actually. Hydroselenic and then acid, all right? So that's how you would name this particular acid. So hydro, hydroselenic acid, all right? Okay, so that's one group of acid or one type of acid. Now, the other type of acid that you need to know how to name are known as oxyacids. And these are acids. Ooh, why did I do that? Okay. Okay, I'm still in this. All right. I meant to press delete. Okay. So let's define oxo acids. Oxo, or oxyacids, I should say. These are acids which contain oxygen, hydrogen, and another element. All right. So just to give you a couple of examples of oxyacids, you have HNO3 and you have HNO2, right? So those are examples of oxyacids because they each contain a hydrogen atom, at least one hydrogen atom. It can contain more actually, and oxygen atoms and some other element. In this case, the other element is nitrogen, all right? So how do we go about naming these particular compounds? Again, I like to start from the corresponding anion, but the rules are a bit different in this particular case. For one, let me just mention from the outset, these acids, they don't start off with hydro in their names, all right? Just to let you know, right? So in the case of binary acids, you always start off with hydro something, right? Hydrochloric, hydrobromic, whatever. In these cases, you're not going to do that. All right. So what I'm going to do is start off, I'm going to use this acid, which is known as nitric acid. So the corresponding anion will be NO3 minus, right? And to get from here to nitric acid, now in this case, you don't have to, you won't have the formation of gas. You go straight to HNO3, which would be in an aqueous solution, which you don't need to show, right? So this is called the nitrate ion. All right. This you can look up again in the tables, right? And then how do we, based on that, name the acid? Well, based on this, the name of the acid is nitric acid. All right. So basically, in order to name an acid where the corresponding anion ends with ATE, then the name of the acid will end with ic acid, right? So that's how that works. Let me give you another example. Sulfuric acid, which is this here, H2SO4, right? That will be formed from SO4 2 minus. So to get from here to here, we add two H pluses. In this case, you added one H plus. And this is called the sulfate ion, which you can look up in your tables. So therefore, the name of this would be, as I said before, sulfuric acid. Again, the name of the acid ends with ic acid. All right, if the name ends with ATE. All right. So if I gave you this, for example, H2C2O4, and I ask you to name it, right? H2C2O4. If I ask you to name it, then what I would do is work backwards to see what the formula for the corresponding anion is, and that would be C2O4 2 minus, right? So you have to add two H pluses to that to get to this, right? So if you look up the name of that anion, the name of that anion is oxalate. All right. So my question to you is, based on this name, what do you think the name of that acid is? If the name of this anion is oxalate, remember the pattern. 8, ic acid, right? So if the name of this anion is oxalate, what's the name of the corresponding acid? Oxalic acid. So that's how you name these acids. If the name of the corresponding anion ends with ATE, then the name of the acid itself ends with ic acid. All right? Okay, any question about this?
What if it ends in IDE?
Well, we just dealt with that with binary acid. Yeah? You said IDE?
Yes.
Right. We just dealt with that with binary acid, right? Okay. For a minute I thought it said ITE because that's what we're going to look at next. All right. Any other questions about this one? Any other questions? Okay, so now we're going to look at another type of binary acid, and okay, let me just clear all this here.
So if it ends in ITE,
Get into that. Okay, so the example we're going to look at to deal with naming another group of acids is I'm going to use HNO2 as an example, and I'm going to use H2SO3 as another example, right? So let's say you're asked to name this acid HNO2, right? So what you do is, just like in the case of the ones that we looked at just now, earlier, we figure out the formula for the corresponding anion, which is NO2 minus, right? Now, if you go to the table and look up the name of this particular anion, it is called the nitrite ion. All right? So the ending here is not ATE, but ITE, right? So according to IUPAC, in order for you to name, and by the way, to get from nitrite to this acid, we add H plus, right? So according to IUPAC, in order to derive the name of this particular acid, this would be the name, nitrous. In other words, we replace the ITE ending with OUS acid. All right. So if the name ends with ATE for the anion, the name of the corresponding acid will end with ic acid. But if the name ends with, for the anion ends with ITE, then the name of the corresponding acid ends with OUS acid. All right. So another example, H2SO3. All right. In this case, the formula for the anion would be SO3 2 minus plus 2H plus, right? The name of this anion is the sulfide ion. So what do you think the name of that acid is?
Sulfurs.
Sulfurous. I mean, I can understand why I said that, but the actual name is sulfurous acid. All right. So that's basically how you name oxyacids. If the name of the corresponding anion ends with ATE, then the name of the corresponding acid ends with OUS acid. I'm sorry, ATE acid. If the name of the anion ends with ITE, then the name of the corresponding acid ends with OUS acid. All right. Okay, so we have dealt with binary acids. We have dealt with oxyacids. There is one particular acid that doesn't fall under any one of these categories. So let's deal with that one. And that particular acid is hydrocyanic acid, right? Now, this does not fall under the category of binary acid because it has 3 elements, right? Remember, binary acids only contain 2, right? It does not fall under the category of oxyacid because it has no oxygen, right? So what IUPAC decided to do is that they treat this as a binary acid for the purpose of naming it, right? So therefore, you can get this acid by dissolving this compound, hydrogen cyanide, which is a very toxic gas, in water, right? So since this is called hydrogen cyanide, the name of this acid is called hydrocyanic acid. All right, so that's a bit of a unique situation. All right, hydrocyanic acid is unique because, as I said before, it's not an oxyacid and it's not a binary acid. All right. Okay, so with that said, you should now be able to complete. You said that's the only part that's left? Yes, so now you should be able to complete that. So I'm going to have you do that at home. In fact, before I forget, what I'm going to do is create a Dropbox for that assignment. So let me go here. So that's assignment number 5, right? Assignment number 5. And oops. Okay, so today's the 3rd. I'm going to let it be due tomorrow, since that's the only part that's left. So, oops, no, I should have done that. I should have done this here. And then this will be tomorrow. Okay, so it's going to be due tomorrow midnight, all right? Okay, so as promised, we're going to look now at chapter 6, balancing equations. And as I was saying, very important skill to master, because after this, you will need to know how to balance equations to do other problem solving exercises. Take one and pass down. Take one and pass down. That's for you. That's for you. And this is for you. All right. And for you guys out there in Zoom, let me, I don't remember if I published it, so let me check it out now.
Was it?
Let
This one has less, but never.
me see here. Okay, I guess I didn't publish it, so let me do that now. So you guys out there in Zoom should now be able to access and download assignment number 6. So let me get you started off. So there are different sections to this. So in section A, it says for the following, you're going to draw a circle around the subscript and draw a square around each coefficient. So remember, the coefficient is the whole number that is placed in front of the formula for each compound. And the subscript would be the numbers that are basically indicating the number of atoms of each element in the formula, right? So therefore, in the case of water, I would draw a circle here, right? In the case of 5CO2, I will put the 5 in a square and put the 2 in a circle. In the case of magnesium, I will put a square here. And in the case of this here, hydrogen peroxide, 3 of them. So I'll put this in a square and put these 2 number 2s in circle, and that's it. All right. Okay, any questions about that? That's relatively simple, right? Okay, so for number 1, here it's asking for you to balance the following chemical equation. Let me just clear this here. Okay, so let me hear some ideas from you guys. How will you go about balancing that first question, number 1, first equation? Well,
Do you put A2 in front of the CO2 oxygen?
you mean here
No, the first one.
or here? For the 2 here? Okay, this should be interesting. And then what?
4 by the other side. C.
Okay. And then what? And that's it? Yeah, that's it actually. Yeah, that's correct. Okay, any questions about that one? Any questions? Any questions? Okay, what about the next one? And you guys out there in Zoom, you can feel free to chip in. Oh, somebody actually said something. Oh, okay, Alejandro, you said 4242. That's in reference to what? Oh, okay, okay, all right. Yes, you guys out there in Zoom, feel free to contribute to the class discussion. Okay, so yes, number 2. Let me hear what you have for number 2. Number 2 should be easy.
Could you put a 2 in front of the H2O2?
Okay, so put a 2 in front here.
2 in front of the H2O.
I would agree with that. That's correct. Okay, very good. What about number 3?
I'm gonna put a 2 in front of the aluminum.
Put a 2 in front of what?
The aluminum.
The aluminum? Okay.
And then the 2 in front of the ALM.
You here?
Mhm.
Okay,
And 3 in front of the aluminum.
okay. And yes, again, I would agree with that. Okay, any questions about this one? Any questions? All right, let me clear this. And scroll down, see what's next. Okay, next one is this one. Let me hear what you have to say about this one. Number 4.
We put a 8 in front of the AG2.
Okay.
And then a 16 in front of the AG.
That's correct. All right, let me clear this. Any questions about this? Any questions? All right, let me clear this. Go down. Okay. Number 5. Okay, let's hear what you have to say about number 5.
Would you put a 3 in front of the CNS?
Put a what?
A 3.
A 3? Okay, I would agree with that. Mhm.
2 in front of the ALB.
Okay. And that's it?
Mhm.
Okay, that's it. Okay, very good. Number 6. How would you balance number 6?
Put a 2 in FD,
Okay. And what else?
3 in front of each.
And then 3 in front of the H2O. And yes, that would achieve the balance. All right, very good. Okay, let me clear this. Scroll down. So the next question says, given the 2 chemical equations, circle the one that is balanced. All right, so basically you're going to look at both equations and say which one is balanced. So for number 7, which one of the 2 is balanced? A or B? A. So the answer will be A, all right? What about number 8? Which of these 2 will be balanced?
A.
Yep. Okay. Here it is. Scroll down. Okay, number 9.
B.
Yeah, B would be the answer. What about 10?
A.
Okay, somebody's saying something. Okay, somebody's asking, just clarifying assignment number 5. The rest of the packet that was given to us, and 10 is a, okay, I'm not sure what you're talking about, Miss Burgos. Maybe you should clarified. But yes, you're correct. This should be the answer is A in that case. Okay, let's continue. Let's see what we have done further. Okay, so basically, this is just a statement with some missing terminologies, missing words. So you need to put the right words in those spaces. So let me hear what you have to say. It says atoms are not
Created.
okay, so created or
Destroyed.
destroyed. So created or destroyed during a chemical reaction. Chemists know that there must be the same number of atoms on each side of the equation. All right. To balance the chemical equation, you must add coefficients in front of the chemical formulas in the equation. You cannot
Change.
okay, I guess you could say that, but you have two spaces. Add or subtract subscripts. All right, and that's how you complete that. Okay, so for the rest of this here assignment, let me just check something here. You see all this plus section C. That's what you're going to complete. You see, I believe that you need to practice this as much as possible so that by the time you get to the next stage, you can balance any equation, right? So you can get started on these. Now you can leave if you want to, right? And go home and sleep if you want to do that. But I'm going to stay here until class time ends. So if you want to hang out here while you're doing these, then I'll help you with any difficulty. That's fine. But if you want to leave at this point, that's fine as well. All right. So it's all up to you. And the same is true for you guys out there in Zoom. While doing these problems, if you have any issues, okay, let me see. Oh, someone was saying that home and sleep sounds nice. Yeah, that's true.
This in the package.
This is first one.
Yes, ma'am.
But these are in the question if they're
Resource stage.
was number one. Would that
Oh,
links
like if there's only one,
if there's only like
right, you can leave that blank because that is understood to be one anyway. So, or you can put one, it doesn't matter. Yeah. All right, take care. Man. Yeah, you can put one or just leave it blank. Both are acceptable
Because
when it comes to balancing equations.
you afford. Get it from the cost. Okay. So loud. It's doing. Two. Boss round. That's two. Author. No. I said two because the charge from two. Other two options. So.
So which section? Section.
Take care.
No, not this one, but the chapter 4. Still three. But this is choices.
So you can get involved through further. I don't know. You can get involved through further. What do you doesn't have charge? Oh, it's right. You need to try to figure out this. No, that's part of how they know this. That if you're gonna share. If somebody has. Yeah, too. So we fully. To.
I'm fussing,
Yeah.
how do we know already when we have our first test, it's next Wednesday?
Professor Nicely.
So our test on Wednesday is chapter 1 to 5, right?
Yeah,
So no chapter 6.
No.
That's 1 to 5.
1 to 5, yeah.
Okay.
He moved, no, the only thing was that it was equal to carbonate enough.
Yeah, but carbonate had to turn 2.
No, 3.
Wait, 3, so. So that's why it would be 2, because carbonate has 3.
Carbonate has 2.
Oh, okay. Oh,
Professor Nicely.
also,
Yes, ma'am.
silence that everybody else has graded and more than mine. But we also get a copy of the second homework in Canvas, like the copy of what I'm not writing in hand, but you never put it in grade.
So I sent you a copy of the graded work, but I didn't put the grade in.
Yes.
Because I save everything I sent on the thumb drive. What's the last name? MILA. Yeah. And you're saying, which assignment was it? Oh, I have, okay.
Oh, yeah.
Okay. I'll have to, oh, do you have,
What?
in fact, hold on, I should have. Let's see. Let me see, I should be able to retrieve it from the email.
Yes, it was an 87 out of 92.
Let me see. Okay.
I didn't get $100.
Here. Search for Miller.
Sure. This is one where I gave you it.
What's the first name? Oh, Ronnie. Yes. Okay, so I did send you assignment number 2. Let's see what this looks like.
For number 6,
Number 6.
for number 6, Molly,
Oh.
Nicole, 3.
Oh, so I sent you chapter 3 and I thought it was 2.
Well, it would be great.
Hold on, let me see.
And then Nichols 3 with phosphate.
Yeah, because phosphate had the charge of grades. PO4 with charge of negative.
Okay,
Yeah.
Probably I need to, but in the subscript, it's 4. I don't have any.
Yeah, but that's for like the phosphate in general, whatever talking about charge wise. Phosphate itself has a charge.
Sent
So
you
you
assignment
bring that
3,
put it in there.
thinking that it was assignment 2.
Okay, thank you.
So let me go here. Grades.
I've submitted everything on the file.
Yeah, that's the, yeah, I don't know what, yeah, I know that, I guess I wasn't paying attention to where I was submitting what. Okay, so basically. For chapter 1, you got. Oh, I got that for chapter 1, okay. So the one that I think it's saved on my thumb drive. Upstairs is chapter 2, but let me just put this in here for chapter. So that's 95. Chapter 3. Okay, so do you have? You said you have chapter 2 or?
Chapter 2 I've already submitted, it's on Canvas, so you have.
Oh. Okay, all right, so I'll have to grade it, okay. So so far, I have 2 of the 3 that
Yes.
I'm just in the system right now, and I'll have to look for the others.
I thought it was odd, you sent me an email, you said like check to make sure that this is uploaded properly. And you sent me a picture of the graded work or something like that. I
Oh, which
thought it
one?
was a bit odd. For assignment, the email that you sent me that says it was assignment 2, but you graded assignment 3.
Oh, okay, yeah, that's a mistake I made. Oh, okay. So I need to grade your assignment too. I think I graded some, I don't know how I missed. Because I have some scores here. Unless I made the error of putting those for assignment 2. Which should be for assignment 2. I'm going to check and see, I have to recheck everything. And correct it.
So that's.
Oh, I just need the last page.
Okay.
You can keep the rest.
Thank you.
Me?
Professor Nicely.
Yes, sir.
Question regarding this one. I just read this assignment for me, and it was shown that the previous one was like second year or so.
Right. It's a nickel, so it's not the same thing as the element.
Okay.
It's a nickel, which is a point, which is an alloy. It's a mixture of metals. Well, you have nickel the element, but when it says a nickel, it's referring to the point.
You didn't.
You know what I'm saying?
Never heard me.
So that would be a mixture, that would be a homogeneous mixture.
That should be just it.
Why is it necessary to use
About
prefixes?
really
Well,
because
the
sodium
answer is
and
use
hydrogen are both.
prefixes in the name of molecular
Wait.
compounds to indicate
pregnant than not.
the number of atoms of each element present in a molecule.
I keep thinking that.
Right, that's why you use the prefix like molar,
Not because it's on.
I know what atoms of each element.
Oh.
You know.
Oh.
Right.
Okay.
Hydrogen's a gas.
Oh, it is now.
This is assignment, you never put a due date, right?
This one, no, he didn't sign it, so is there?
Ah.
Oh, wait,
Did you not say?
this was due Friday?
Yes, sir.
You did the same.
Maybe he didn't put it.
Oh, maybe you look for this one. Maybe you should have it.
It's too
Oh, then that
But he doesn't. Emphasis, yeah.
Oh, okay, yeah. So we're not done.
So we'll be doing that, but it's due.
All right, let me, put some here.
Guess what parked by today?
The parking lot.
Guess who I find today?
Oh, I thought you said where you parked. I don't know who.
Yes.
Okay, so I think I think the mistake is that, I'm making for
Is it
other
what-
students.
Professor Nicely.
It's a wrong assignment.
I did, yes.
So I need to go and check that out. Yeah, same thing. So in your case, it's.
Who is it?
It was you.
For here.
Oh, wait, really?
I know.
Yeah.
This one we can do.
Okay.
Very deep.
Exactly, this is a lot in school anymore. Oh, yeah.
What? All of them.
I don't really like this enough for school.
Oh, somebody.
What? Oh. Lord.
I hope this is possible.
Professor Nicely.
All the things for next semester. You have our classes already?
I'm on my day, so. They open my registers, but it just goes through on them.
Oh,
Did you put it on your schedule?
no, not yet. But you met up with your advisor, right? Then you said it.
You said I had to schedule a meeting, so I scheduled a meeting. I'm gonna go on the 9th. He's a busy dude, yes.
I was about to say, did you ever find out if you still have to take children's literature or whatever for
I have to figure that out. What is up with these classes? It's funny.
I'm like
These
90%
experts one of these
sure.
questions.
I'm like 90% sure we don't have to take that. Cause
I don't believe these secrets. Did you already go over?
Remember like Joseph literature, but doesn't have anything to do with biology.
I don't. I had to take classes psychology. Because I have to do that. So I have a question about this one date.
Yes, ma'am.
But it's not ammonium. I know that's.
Which one? Oh, you can just write ammonium.
Oh, really?
Yeah, according to IUPAC, some common names can be used for ammonia and water.
Oh,
You
okay.
so just write
So
ammonia.
just the one got it.
Mhm,
Thank you.
no
Have
problem.
a good day.
Take care.
Professor Nicely. Hello.
Oh, you're too. Oh, somebody's asking when is our first test? That will be next week, Wednesday, right? If I remember correctly, yeah.
Yeah, can you hear me?
So Ashley, next week, Wednesday would be your first test. And it's gonna cover chapters 1 through 5. All right?
Oh, I thought it was 1 through 4.
Is that in the testing center?
No, we're gonna do it here, no.
You're gonna get the sheets of the tables and stuff?
Oh, yes, I'm gonna provide the tables, so the only thing you need to bring or use is a pen and a calculator. And I'm gonna use the first hour and 15 minutes of class for the test, and then we're gonna have a normal class afterwards.
So, can you hear me?
Okay, so let me see here.
Hello?
Okay, so that's it. Yes, sir.
I have two questions. So in oxalic acids, why hydrogens are not written?
I'm sorry.
In oxalic acids, why hydrogens are not written?
Oh, honestly, that's just the rule. I mean, yeah, that's just the rule. When it comes to oxyacids, you don't, okay, so somebody's asking, how am I supposed to take the test? So you're not able to come to class to do the test, Miss Jordan? Oh, ah, okay, so, I guess I'll have to do a special thing for you since you're over in the Citrus campus. So, what I will do is send the test to, what's her name? Miss Russell. Yes, I'll be able to send it to Miss Russell in the testing center so that you can do it there. All right, so, I'll do that. Now, I'm gonna need your help. So, you need to remind me, since the test is on what, Wednesday, remind me on Tuesday evening. Send me an email. Because knowing me, I'll forget, right? Send me an email just to remind me to send the test to the testing center for you so that you can do it. All right? Okay, so let me see what this person is saying. Okay, I will email him also my assignment to it. Yes, I need to grade, yeah, and you're not the only one. I'll be working on that before this week is ended. Apparently I missed some of, I missed grading some of the assignment too, so. I'll make sure I do that, and you'll have that. You'll have that sent back to you, so you can use that to review. Yeah, you too. Three. Okay, so in this case here, you know, Benson,
Answer.
okay, good. So in this case here, you have three carbons here, and you have only one here, right?
So that is
So I'll put a three here, okay? And then over here, you have 7 plus 1 is 8 hydrogens. You have 2 here. So I'll put a 4 here. Okay? Now we have to concentrate on oxygens. We have a total of 1 plus 2, 3 oxygens here. And here we have 6 plus 4, and that gives you 10 oxygen, right? So that means that what they put here, that plus that should give you 10, right? So what I would put here is 9 over 2, because 9 over 2 times 2 gives you 9, plus 1, 10. You see what I'm saying?
Yeah.
But that would not be the end of it.
And then I'll multiply it
But
by
I
two.
write 2 by 2, exactly, and that's where you get friends.
So when we are left with odd oxygens or odd hydrogen.
Right,
we
you have to use like a fractional number to
And then
balance.
we multiply a whole. bit.
Exactly.
Thank you.
Okay, time for me to. Get over there. Okay, so for you guys out there, Zoom, I'm signing off now.